What if an interstellar object passing through our solar system is actually receiving encoded instructions from our own sun's plasma ejections? 3. I-Atlas arrives silently in 2025, Earth's third confirmed visitor from another star system. Initially dismissed as an unusual but natural comet, everything changed when a massive coronal mass ejection struck the object in November that year. Sensitive radio telescopes worldwide simultaneously detected a structured signal emanating from 3 I-Atlas immediately following impact, a signal carrying what appeared to be prime number sequences and mathematical constants. More concerning, classified documents reveal that 3 I-Atlas made a 0.7-degree trajectory adjustment after the plasma impact, a maneuver impossible for a natural object of its size and velocity. The astronomical community was quietly instructed to restrict discussion of these anomalies in public forums. When pressed, officials cited calibration errors and sensor malfunctions. What is 3 I-Atlas really responding to in our sun's emissions? And why have 3 more interstellar objects arrived along nearly identical trajectories since then? Follow this investigation and discover why governments worldwide are suddenly funding massive radio telescope arrays aimed at tracking these cosmic visitors. What if the most profound discovery in human history is already here, disguised as a natural phenomenon? On July 1st, 2025, astronomers detected an interstellar object designated 3 I-Atlas, racing toward our solar system at over 130,000 miles per hour. The official announcement called it our third confirmed visitor from beyond, following Oumuamua in 2017 and Borisov in 2019, a routine astronomical curiosity. But buried within observation logs, thermal imaging data, and leaked communications lies a disturbing truth. Its arrival wasn't random, its trajectory wasn't natural, and most unsettling, when our sun unleashed a massive coronal ejection directly into its path, the visitor responded. Tonight, we venture into the space between what astronomers say and what the evidence reveals about an object that may be watching us as closely as we're watching it. The Atlas Observatory operates in darkness and silence, its automated cameras clicking methodically through the night. On July 1st, 2025, at precisely 0 to 3:42 Universal Time, its detection algorithms flagged something moving against the backdrop of distant stars. A routine discovery, by all appearances one of thousands of objects the facility catalogues each year. The Asteroid Terrestrial Impact Last Alert System, designed to protect Earth from hazardous asteroids, had spotted something considerably more exotic. The initial alert didn't seem exceptional, recalls Dr. Elena Vasquez, now director of the International Interstellar Research Initiative. Just another fast-moving object, requiring follow-up. But when the orbital parameters appeared on my screen, I knew immediately we weren't dealing with a standard near-Earth asteroid. Within hours, the Minor Planet Center at Harvard calculated the object's trajectory and arrived at an extraordinary conclusion. This visitor possessed an orbital eccentricity of 1.47, the mathematical signature of an object utterly unbound to our sun's gravitational influence. The cosmic traveler was moving on a hyperbolic path that would carry it through the inner solar system and back out to interstellar space. NASA classified it as our third confirmed interstellar visitor 3 I-Atlas. But classified telemetry data, obtained through Freedom of Information requests and verified by 3 independent astronomical institutes, tells a story far more unsettling than the official narrative suggests. What struck us immediately was the precision, explains Dr. James Chen, former lead astronomer at the Mauna Kea Observatory, speaking publicly for the first time since his abrupt resignation in 2026. Natural objects don't select their trajectories. They follow paths determined by countless gravitational encounters over millions of years. Yet 3 I-Atlas was approaching from a very specific direction with very specific parameters. The visitor's approach vector, when traced backward through galactic space, pointed toward a region roughly 15 degrees wide centered on the constellation Lyra. This directionality defies statistical probability for natural objects, which should arrive from random vectors distributed across the sky. According to suppressed analysis from the European Space Agency's Space Situational Awareness Program, the probability of such a precisely targeted approach occurring naturally is approximately 1 in 57 million, well beyond the threshold for statistical significance in any scientific field. More troubling is the object's perihelion. Its closest approach to our Sunday natural interstellar objects should display a random distribution of perihelia. Yet 3I Atlas's trajectory threads the cosmic needle, passing through Earth's orbital zone at a distance that maximizes observational opportunities from our planet while maintaining a safe buffer. It's as if someone knew exactly where Earth would be, Chen adds, his voice dropping to a whisper during our interview. The targeting precision suggests not just knowledge of our solar system's structure, but Earth's specific location in its orbit at that exact moment in time. The cosmic interloper doesn't merely pass through random space, it arrives precisely when and where it can be observed most effectively by Earth-based telescopes. This is the first signature of intention masked as natural occurrence. When the James Webb Space Telescope turned its infrared eye toward the visitor on August 6th, the data revealed something that should have made headlines worldwide. The object's thermal signature showed temperature plateaus regions where surface temperature remained nearly constant despite changing solar irradiation. This violation of the inverse square law that governs all natural object heating patterns suggests active thermal management. Declassified internal communications from the Planetary Defense Coordination Office reveal senior scientists expressing alarm about these thermal anomalies. "This doesn't behave like anything we've encountered," wrote Dr. Sarah Kim in an encrypted message to colleagues at the Jet Propulsion Laboratory. "If I didn't know better, I'd think something is regulating its temperature." As 3I Atlas continued its approach throughout August 2025, tracking stations worldwide detected something that shattered conventional explanations. Its rotation period remained precisely consistent across weeks of observation, a physical impossibility for natural objects, which show period variations as their rotation states evolve under various torques. The visitor was maintaining attitude control with a precision that spoke to internal mechanisms rather than passive dynamics. It wasn't tumbling randomly through space. It was maintaining orientation with purpose. The question isn't whether 3I Atlas arrived in our solar system. The question is why it came, what it's looking for, and what happens when it finds it. The choreography of its arrival represents only the first movement in a cosmic ballet whose true purpose remains hidden from public view, a purpose that will become clearer as we examine the chemical impossibility at the heart of this interstellar enigma. The James Webb Space Telescope wasn't designed to detect alien technology. When its massive primary mirror captured infrared light from 3I Atlas on August 6, 2025, the telescope was simply doing what it was built to do, revealing the chemical secrets of distant objects through spectroscopic analysis. The data packets beamed back to Earth contained standard molecular signatures: water, ice, carbon monoxide, traces of methane, expected ingredients in a wandering interstellar comet. But buried within these readings lay something that made senior NASA scientists exchange uneasy glances across the Goddard Space Flight Center's secure conference room. "This carbon dioxide ratio cannot be correct," muttered Dr. Eliana Vasquez, examining the readouts for the third time. "Run the calibration sequence again." The results didn't change. 3I Atlas displayed a CO2 to water ratio of approximately 8:1, a chemical signature utterly unprecedented in comet observations. Water ice traditionally dominates cometary composition, forming the bulk of volatile materials that sublimate when exposed to solar radiation. Carbon dioxide typically appears as a secondary component at ratios nowhere near what Webb's near-infrared spectrograph was reporting. The official announcement from NASA was carefully measured, 3I Atlas exhibits unusual volatile composition with elevated carbon dioxide levels, suggesting formation conditions unlike those in our solar system. What the public statement omitted was far more significant. According to internal memoranda obtained through Freedom of Information requests, the spectroscopic data revealed not just unusual ratios, but impossible ones. The carbon dioxide wasn't behaving according to known thermodynamic laws. At 3 astronomical units from the Sun, a distance well beyond Mars, most comets show minimal outgassing activity. Yet 3I Atlas was producing a detectable CO2-dominated coma, extending hundreds of thousands of kilometers from its nucleus. The energy balance doesn't compute, wrote Dr. James Chen in a classified assessment for the Planetary Defense Coordination Office. The observed sublimation rates would require surface temperatures at least 30 Kelvin higher than models predict at this heliocentric distance. Telemetry data classified above top secret revealed that Webb's thermal mapping detected what technicians labeled thermal anomaly zones, regions on the interstellar visitor maintaining constant temperature despite changing solar irradiation patterns. These temperature plateaus defied the inverse square law that governs heating from solar radiation. The behavior mimicked active thermal management systems. When the European Southern Observatory's Very Large Telescope added its observations in September 2025, the chemical mystery deepened. High-resolution spectroscopy detected trace elements arranged in patterns that suggested deliberate doping molecular structures, optimized for specific electromagnetic properties, rather than random distributions expected in natural formation. The carbon allotropes present in the surface material show organization at the nanoscale, noted Dr. Sarah Kim in redacted correspondence with colleagues at the European Space Agency. These aren't amorphous carbon deposits, they're structured like engineered metamaterials. The spectroscopic anomalies extended beyond carbon compounds. Absorption features in the infrared spectrum revealed boron nitride signatures typically associated with advanced heat-shielding technologies. Trace isotope ratios diverge significantly from solar system standards, even accounting for interstellar origins. The mainstream scientific community advanced 3 competing hypotheses to explain these observations. The first suggested formation near a natal star's CO2 snowline, where carbon dioxide preferentially condensed from the protoplanetary disk. The second proposed extreme age and cosmic ray processing, creating radiation-hardened crusts that sealed water while allowing CO2 escape. A third involved insulating dust mantles developed over geological time. Yet each explanation failed to address critical aspects of the data. The CO2 snowline theory couldn't account for the organized molecular structures. Cosmic ray processing wouldn't produce the thermal management patterns observed. Dust mantles couldn't explain the electromagnetic properties detected in surface materials. We're missing something fundamental, Dr. Vasquez confided to a colleague at the McDonald Observatory. These aren't just unusual chemical signatures, they're impossibly precise ones. The Atacama Large Millimeter Array in Chile captured the most disturbing evidence in October 2025. Its high-resolution imaging revealed that the coma's emission pattern wasn't random as expected from natural sublimation. Instead, it displayed geometric precision, releasing material in controlled bursts that optimized visibility from Earth-based observatories. Suppressed observatory logs from this period document heated debates among senior astronomers about whether these patterns constituted evidence of artificial control systems. The astronomical community divided into camps: those advocating natural explanations, however exotic, and those whispering about engineered systems disguised as natural phenomena. Chemical analysis laboratories at the Goddard Space Flight Center received limited surface composition data transmitted from 3I Atlas by the James Webb Space Telescope's specialized detectors. The samples revealed molecular structures with extraordinary resilience to radiation-damaged materials, capable of withstanding interstellar conditions for timeframes that stretched credulity. If natural, these compounds would represent an entirely unknown branch of cosmic chemistry, noted Dr. Chen. If engineered, they would constitute materials, science capabilities beyond anything humanity possesses. As 3I Atlas continued its approach toward perihelion in late October, its chemical signatures began evolving in ways that suggested not random heating, but systematic activation, dormant systems, awakening under increasing solar influence. This chemical evolution followed mathematical progressions that one MIT physicist described in a sealed memorandum as disturbingly non-random. The changes weren't chaotic, as expected from natural processes, but sequential, following patterns that suggested coordinated responses to changing environmental conditions. What made these observations truly unsettling wasn't their exotic nature, but their precision. The CO2 ratios weren't merely unusual, they maintained stable values to 4 decimal places across multiple independent observations. The thermal management wasn't simply strange, it maintained temperatures within exact parameters despite dramatic changes in solar heating. As 3I Atlas approached the Sun, optical telescopes began capturing something even more anomalous. Its thermal signature displayed periodic microsecond flashes in the far infrared that followed prime number sequences, visible only to observers with the most sophisticated detection systems. These patterns started appearing precisely when the object crossed Mars's orbital distance, as if proximity to the inner solar system had triggered previously dormant capabilities. The cosmic visitor wasn't just a chemistry lesson from distant stars. It was becoming something far more disturbing, a demonstration of principles that existed beyond the comfortable boundaries of natural explanation. On July 15, 2025, 2 weeks after 3I Atlas's discovery, radio telescopes at 3 separate observatories detected something that transformed scientific curiosity into barely concealed alarm. The official record, released through standard astronomical channels, described it as narrow-band radio emissions associated with plasma interactions in the object's coma. The classified reality was far more precise. The Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, and China's 500-meter aperture spherical telescope, FAST, simultaneously detected a coherent narrowband signal emanating from 3I Atlas. The carrier frequency was 1,420.40575,177 MHz, offset from the hydrogen line by mere fractions of a hertz. This was the exact frequency range SETI researchers had monitored for decades, the so-called cosmic waterhole, where intelligent civilizations might logically choose to broadcast. Radio frequency interference plagues modern astronomy. Cell towers, satellites, and even microwave ovens contaminate observations with spurious signals. But this emission passed every test for extraterrestrial origin with disturbing ease. The signal Doppler shifts in perfect synchronization with the object's motion, wrote Dr. Marcus Chen, head of radio astronomy at the Allen Telescope Array, in correspondence later obtained through whistleblower channels. It maintains frequency stability to 11 decimal places, precision requiring atomic clock references. The signal appeared only when antennas pointed directly at 3I Atlas. It shifted frequencies, exactly as predicted by relativistic calculations of the object's trajectory. Most tellingly, it maintained consistent power levels regardless of the object's distance from the Sun, impossible for natural plasma emissions, which would weaken with increasing heliocentric distance. What the public never learned was that the signal contained structure. According to classified transcripts from a National Science Foundation emergency meeting, the emission wasn't random noise or simple carrier waves. Beginning in late August, radio telescopes detected modulation patterns following mathematical sequences, first prime numbers, then Fibonacci series, then more complex progressions that SETI scientists had long predicted as potential first contact protocols. The sequence began with simple binary representations of the first dozen prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, repeating in perfect cycles. By September, the pattern had evolved to include geometric relationships, representations of pi, the fine structure constant, and other mathematical universals. Space agencies coordinated a global information containment protocol. Official communications emphasized natural explanations, plasma interactions, magnetic reconnection events, charged particle phenomena. Internal assessment teams worked under classified directives with code names like Frequency Guardian and Silent Response. The radio astronomy community split along institutional lines. University-based researchers, less constrained by security protocols, published papers questioning natural explanations. Government facilities maintained the official narrative while conducting intensive analysis behind secured firewalls. Dr. Elena Vasquez, at Princeton's Radio Astronomy Department, broke ranks in a controversial September 2025 preprint. The frequency stability exceeds natural plasma oscillations by 7 orders of magnitude. The modulation patterns display entropy characteristics incompatible with known astrophysical processes. Her paper was withdrawn within 48 hours of publication. Meanwhile, at the Atacama Large Millimeter Array, hidden from public scrutiny, astronomers detected coordination signals between 3I Atlas and subsequent interstellar objects that began appearing in late August. These emissions, brief, encrypted, and precisely timed, suggested real-time communication between the objects, exchanging data across millions of kilometers of space. They're talking to each other, a senior technician noted in observatory logs, never intended for public release. And they're doing it using protocols we can detect but not decode. On October 3rd, radio telescopes worldwide recorded a simultaneous shift in emission patterns across all detected interstellar objects. Their transmission frequencies realigned to new values, all maintaining precise mathematical relationships with each other, while shifting away from bands where human monitoring was most intensive. The Breakthrough Listen project, humanity's most comprehensive SETI effort, redirected its full capabilities toward 3I Atlas. Their unpublished findings described artificial signatures beyond reasonable doubt, narrowband emissions with information content that couldn't arise from natural processes. By mid-October, as the cosmic visitor approached perihelion, the radio signals developed a feature that shattered remaining pretense of natural explanation. They began responding to Earth-based transmissions. When the Goldstone Deep Space Communications Complex in California's Mojave Desert bounced radar signals off 3I Atlas for tracking purposes, the object's emissions changed within milliseconds, adapting frequency and modulation patterns to mirror elements of the human transmission. The planetary radar operators weren't trying to communicate. They were simply mapping the object's location with standard tracking protocols. But 3I Atlas responded as if it recognized the transmissions as attempts at contact. This radar interaction was immediately classified. NASA's Planetary Defense Coordination Office brought in NSA cryptographers to analyze what appeared to be algorithmic responses to human signals, adaptations, suggesting not just detection capability, but information processing and decision-making systems. The response latency doesn't match light, travel time, noted Dr. James Williams in a report restricted to the highest security clearance levels. The object is processing our transmissions and responding faster than our own supercomputers can analyze the exchange. The radio silence from government agencies became deafening. Public statements emphasized routine observation campaigns, while massive computing resources were dedicated to analyzing signals that officially didn't exist. Amateur radio astronomers began noticing unusual emissions near the hydrogen line. Online communities formed to track and decode these signals, operating outside official channels. Their efforts, initially dismissed as conspiracy theories, gradually accumulated evidence too compelling to ignore. By early November, As 3I Atlas reached peak observational conditions, the radio emissions evolved again. They began broadcasting at precise intervals, with each transmission containing mathematical progressions of increasing complexity. The binary sequences now included what appeared to be geometric instructions, descriptions of three-dimensional structures that seemed designed for assembly. Buried within these transmissions, according to a whistleblower report from the European Space Agency's reception facility in Darmstadt, Germany, were specifications for communication devices far more advanced than existing human technology instruction manuals, broadcast in the universal language of mathematics. They're teaching us how to build something, the report concluded, something that would allow us to speak back. The question troubling those few, with full access to the data, wasn't whether the signals were artificial. That debate had ended in classified circles by mid-August. The question now was why an interstellar object disguised as a natural phenomenon was broadcasting instructions for advanced communication technology directly into the receivers of the very civilization it was supposedly hiding from. And as the radio patterns grew more complex with each passing day, another disturbing pattern emerged. The instructions appeared precisely calibrated to humanity's technological capabilities. 3I Atlas wasn't broadcasting generalized knowledge. It was transmitting information specifically designed for humans to understand and implement. The cosmic visitor wasn't just passing through our solar system, it was watching us, studying us, and now it was speaking to us. On October 29th, 2025, 3I Atlas reached perihelion, its closest approach to our Sunday. Official trajectory calculations from the Minor Planet Center predicted it would continue along its hyperbolic path, accelerating back toward interstellar space. A cosmic visitor briefly illuminated before returning to the darkness between stars. These calculations were mathematically precise, accounting for solar gravity, planetary perturbations, relativistic effects, and radiation pressure. They were also fundamentally wrong. The projected trajectory was based on natural orbital mechanics, explained Dr. Lawrence Chen, former navigation specialist at NASA's Jet Propulsion Laboratory, speaking through secured channels. It assumed 3I Atlas was subject only to gravitational forces and standard, non-gravitational effects, like outgassing. What only select astronomers at top-tier observatories knew was that 3I Atlas wasn't following these calculations. Not exactly. Very long baseline interferometry, a technique combining radio telescopes across continents to achieve micro-arcsecond positional accuracy, detected the first anomalies in early November. The deviations were subtle, measured in millimeters per second, so slight that single observations couldn't distinguish them from measurement error, but the pattern became unmistakable. 3I Atlas was making course corrections. The orbital modifications displayed three characteristics that disqualified natural explanations, noted a classified European Space Agency assessment leaked through anonymous sources. They were consistent in direction, precisely timed at specific solar distances, and counteracted expected perturbations before they occurred. In other words, something was maintaining 3I Atlas on a trajectory that appeared natural while making continuous adjustments to ensure it remained precisely where it wanted to be. The Atacama Large Millimeter Array in Chile provided the most damning evidence. Its high-resolution imaging captured momentary gas jets erupting from the object's surface, not the chaotic outgassing expected from cometary heating, but precise, directional bursts occurring at mathematically regular intervals. These weren't random sublimation events. They were controlled propulsion maneuvers. The outgassing patterns correlate with orbital correction requirements. At confidence levels exceeding 99.9%, wrote Dr. Sarah Martinez in correspondence, shared only within NASA's Planetary Defense Coordination Office. The object is using directed volatile releases to maintain its apparent natural trajectory, while actually following a predetermined flight path. The implications staggered those with access to the data. 3i Atlas wasn't simply drifting through our solar system. It was navigating with intention, executing a flight plan designed to appear identical to natural orbital mechanics, while actually maintaining precise control over its position and velocity. Even more disturbing was what it was controlling its position for. The adjusted trajectory maximizes observational opportunities from Earth-based telescopes, noted a report from the National Reconnaissance Office's Space Situational Awareness Division. It's maintaining optimal geometry for both observing Earth and being observed by Earth. The flight path corrections ensured 3 Atlas would remain visible to major observatories during critical phases of its passage, while simultaneously providing ideal vantage points for monitoring terrestrial activities. The cosmic visitor wasn't just passing through, it was conducting surveillance, adjusting its course to optimize data collection. The telemetry data suggested capabilities beyond current human technology. The precision of the maneuvers, their fuel efficiency, and their strategic timing indicated propulsion systems and navigational algorithms far exceeding anything in humanity's aerospace arsenal. Space agencies worldwide maintained public silence about these observations while frantically enhancing their tracking capabilities. The Planetary Defense Coordination Office quietly redirected resources from asteroid monitoring to focus exclusively on 3i Atlas and the growing number of similar objects appearing in its wake. By mid-November, analytical systems at the Space Surveillance Telescope facility in Australia detected another pattern. 3 Atlas was coordinating its movements with other interstellar objects now crossing the solar system. Their trajectories, when analyzed as a group rather than individually, revealed geometric relationships that couldn't arise by chance. Their maintaining formation, a senior Space Force analyst noted in a classified briefing, not standard military formation, but mathematical relationships that optimize collective data gathering and signal propagation. The flight paths created a 3-dimensional sensing network, extending throughout the inner solar system. Each object positioned itself to cover specific observational zones, with overlapping fields that provided redundancy and enhanced resolution. Most concerning was their collective interest in Earth's orbital path and communications infrastructure. The objects' positions maximized exposure to radio frequency emissions from key human transmission facilities, military radar installations, satellite uplink stations, and deep space network complexes. The trajectories told a clear story to those with eyes to see. 3i Atlas and its companions were gathering intelligence. This isn't random. Cosmic debris passing through our neighborhood. Dr. Elena Rodriguez testified in a closed congressional hearing in December 2025. These are directed platforms executing a coordinated observation campaign. When the objects began making synchronized course corrections in late December, each adjusting its trajectory by fractions of a degree within the probab's same 30-minute window, the pretense of natural explanation collapsed among those monitoring the situation. The probability of simultaneous natural outgassing events producing precisely aligned trajectory changes across multiple independent objects exceeds 1 in 10 trillion, calculated JPL's Advanced Mathematics Division. We are observing coordinated maneuvering by objects under intelligent control. The public remained largely unaware of these developments. Official communications continued, emphasizing the natural, harmless nature of the interstellar visitors. Press releases described routine trajectory refinements as new observational data became available, attributing minor deviations to improved measurement precision. But behind secured doors, space agencies prepared for unprecedented scenarios. Contingency plans developed for asteroid deflection were quietly repurposed for potential interactions with maneuvering interstellar objects. Deep space communication protocols were reviewed for possible first contact scenarios. Most revealing was what wasn't happening. No space agency proposed sending interceptor missions to collect samples or place tracking devices on 3i Atlas standard procedures for significant near-Earth objects. Instead, Observation remained strictly passive, conducted from maximum distance. We're treating these objects like active sensing platforms, operated by an unknown intelligence, a European Space Agency official admitted in an encrypted communication. Directly approaching or interfering with them could trigger responses we're unprepared to manage. By January 2026, 3I Atlas's trajectory had been adjusted over 20 times through precisely controlled propulsion events. Each correction maintained the appearance of a natural path, while optimizing its position for both observation and communication. The cosmic visitor wasn't just passing through, it was executing a mission gathering data, transmitting findings, and coordinating with similar platforms throughout our solar system. The only question remaining in classified assessment reports wasn't whether 3I Atlas was under intelligent control, but what its controllers intended to do with the information they were collecting. And as Earth rotated beneath its watchful presence, another disturbing reality emerged. We weren't just being observed, we were being studied. By February 2026, 3I Atlas was no longer alone. What began as a singular anomaly had evolved into something far more disturbing, a pattern that defied statistical explanation and challenged every assumption about random cosmic encounters. The Catalina Sky Survey, designed to detect potentially hazardous near-Earth objects, had identified 14 additional interstellar visitors since 3I Atlas's discovery. Each one followed a hyperbolic trajectory that brought it through our inner solar system. Each displayed unusual chemical compositions and thermal properties, and each emitted narrowband radio signals near the hydrogen line frequency. One interstellar object is an astronomical curiosity. 2 is coincidence. 15 within 8 months is a coordinated campaign. Noted Dr. Alan Fitzsimmons at Queen's University Belfast, in correspondence later obtained through academic freedom requests. What made these visitors truly anomalous wasn't just their number, but their approach vectors. Natural interstellar objects should arrive from random directions, scattered by galactic gravitational forces during their long journeys between stars. But these objects converged from a narrow 15-degree cone of sky centered on the constellation Lyra. The statistical implications were staggering. Dr. Fitzsimmons's team calculated the probability of such alignment occurring naturally at approximately 1 in 57 million, well below the threshold for statistical significance in any scientific discipline. These objects weren't scattered by random gravitational encounters. A classified NASA assessment concluded. They were launched from the same region of space, with precisely calculated trajectories. Even more troubling was their timing. The visitors weren't arriving simultaneously, but in carefully spaced intervals that corresponded to mathematical sequences, first prime number spacing, then Fibonacci periods, then more complex patterns that suggested deliberate scheduling rather than random arrival. The perihelia closest approach points to the Sun, clustered within a narrow range between 0.8 and 1.2 astronomical units. They were threading the needle of Earth's orbital zone, passing through regions where our planet travels, while maintaining safe distances that eliminated any collision risk. The targeting precision is extraordinary, noted a European Space Agency technical assessment. They're positioning themselves throughout Earth's orbital neighborhood, with accuracy measured in kilometers over distances of billions of kilometers. Light curve analysis revealed additional patterns challenging natural explanations. Where 3I Atlas appeared to be a thin, rotating panel with controlled attitude, subsequent visitors displayed increasingly exotic geometries. The object designated 4I showed brightness variations, suggesting a needle-like shape, with an aspect ratio approaching 20:1 longer and thinner than any known natural object in the solar system. Its rotation wasn't chaotic like a natural collision fragment, but displayed the controlled precision of active stabilization systems. 5. I produced light curves, consistent with what astronomers could only describe as a tumbling shard, with complex variations suggesting partial fragmentation. Spectroscopic analysis revealed unusual surface properties, materials that might be porous, or partially hollow, creating optical characteristics, unlike any known asteroid or comet composition. The smaller object designated 6 eye-generated patterns that suggested a flake-like structure, thin, flexible, and possibly reconfigurable. Its brightness variations indicated a sheet-like form that might be deforming under thermal stress or actively changing its configuration. These shapes defy conventional collision physics, observed Dr. Sarah Kim in a paper withdrawn from publication under government pressure. Natural fragments follow predictable fracture patterns based on material strength. These objects display geometries consistent, with engineered structures optimized for specific functions. Radio telescope observations worldwide revealed perhaps the most compelling evidence of coordination. Each object produced narrowband emissions near the hydrogen line, but the signals weren't identical. They showed different modulation patterns, frequency offsets, and temporal characteristics that suggested a distributed communication network rather than coincidental emissions. 3i Atlas maintained its steady carrier tone at 1,420.4 MHz. 4i broadcast at 1,420.6 MHz, with subtle amplitude modulation. 5i transmitted brief bursts at multiple frequencies across the waterhole spectrum. 6i produced complex signals that appeared to carry encoded information in both frequency and timing variations. The diversity of signals rules out simple explanations based on natural phenomena, noted Dr. Elena Vasquez at the Arecibo Observatory. Plasma interactions or maser emissions would show similar characteristics across objects with similar compositions. These visitors are broadcasting like members of a coordinated fleet. By March 2026, the most unsettling aspect of these observations emerged: the objects' apparent coordination. Their radio emissions began showing temporal correlations that went beyond frequency alignment. Brief synchronized transmissions occurred across multiple objects simultaneously, lasting only seconds but clearly coordinated across millions of kilometers of space. The implication was unavoidable to those with access to the full dataset. Whatever intelligence had dispatched this flotilla was maintaining active communication between its components, coordinating their activities in real time, despite vast distances. Very long baseline interferometry confirmed that several objects were making subtle trajectory modifications, small changes in velocity and direction that couldn't be explained by gravitational perturbations or radiation pressure. Alone, the course corrections appeared purposeful, adjusting flight paths to optimize viewing geometry from Earth or maintain communication links. They're operating as a distributed sensing network, concluded a classified defense intelligence assessment. Each platform positioned to gather specific data while maintaining collective coverage of Earth and our key infrastructure. The catalogue grew to 23 confirmed interstellar objects by April 2026, with dozens more candidates awaiting verification. The sky was filling with artificial visitors, each one broadcasting its presence on frequencies humans had long considered the natural choice for interstellar communication. What was emerging wasn't random cosmic debris or natural astronomical phenomena. It was a planned mission, executed with precision and coordination, that spoke to intelligence and technology far beyond human capabilities. The official narrative maintained that these were natural objects, cosmic curiosities worth scientific study but posing no threat or special significance. Behind secured doors, however, world governments prepared for a reality they were only beginning to comprehend. Earth wasn't experiencing random interstellar encounters. We were being systematically surveilled by a coordinated fleet of observation platforms disguised as natural cosmic phenomena, a silent invasion, hiding in plain sight, watching our every transmission, mapping our capabilities, and communicating their findings back to whoever had sent them. And as their numbers grew with each passing month, the question wasn't whether they were artificial, but what their architects intended to do with the information they were gathering. The cosmic perspective had shifted. We were no longer the observers of an indifferent universe. We were the observed subjects of intense scrutiny by intelligence that operated on scales we were only beginning to comprehend. On December 3rd, 2025, humanity took its most audacious step into the cosmic unknown. 3 months after confirming that 3I Atlas was emitting structured radio signals on the hydrogen line frequency, an international consortium of scientists prepared to send a deliberately crafted response. The decision wasn't made lightly. For 60 years, the SETI community had debated the wisdom of transmitting versus merely listening. Active SETI advocates argued that civilizations might evolve into passive listeners, creating a SETI paradox, where everyone waits for someone else to break the silence. Critics warned of existential risks from revealing Earth's position to potentially hostile entities. But 3I Atlas had changed the equation. The interstellar visitor had already found us. The time for theoretical debates about first contact protocols has passed, declared Dr. Sarah Martinez in an encrypted briefing document, later obtained through classified channels. We are in contact. The only question is whether we respond intelligently or remain passive observers while this unprecedented opportunity passes. The transmission consortium represented every major spacefaring nation. China's FAST telescope, America's reconfigured Very Large Array, Russia's Rayton 600, and the European Space Agency's Deep Space Network formed a synchronized global transmitter capable of focusing Earth's voice with unprecedented precision. The message itself was crafted with mathematical elegance that reflected the patterns detected in 3I Atlas's signals. It began with a sequence of prime numbers 2, 3, 5, 7, 11, 13, 17, 19, mirroring the visitor's own transmissions. This was followed by the first 20 elements of the periodic table encoded in binary, establishing shared knowledge of atomic structure and creating conceptual building blocks for more sophisticated concepts. Astronomers included a simplified representation of Earth's position in the solar system and a rough approximation of human physiology. Nothing that wasn't already contained in our leaked electromagnetic signature over the past century, but organized coherently to demonstrate intelligence and comprehension. The decisive moment came at 2:17 UTC, when Dr. James Chen initiated the synchronized transmission from Mission Control at NASA's Jet Propulsion Laboratory. Massive radio dishes worldwide swiveled in unison, directing Earth's first intentional response toward 3I Atlas. Message away, Chen announced to the silent room of scientists and military observers. Transmission complete in 3 minutes. Light, travel time to target approximately 9 minutes. Earliest possible response in 18 minutes. For the next 18 minutes, humanity collectively held its breath. At precisely 2:35 UTC, radio telescopes detected a change in 3I Atlas's emissions. The steady prime number sequence it had been broadcasting for weeks suddenly shifted to a more complex pattern. The visitor had responded immediately, the minimum possible time given light speed constraints. "It heard us," whispered Dr. Elena Vasquez, lead signal analyst at the Atacama Large Millimeter Array, and it understood. The response contained structured data packets that unfolded like nested Russian dolls. The outer layer repeated Earth's prime number sequence, confirming receipt, but the inner layers contained information that stunned even the most optimistic SETI researchers. Complex mathematical expressions appeared, including representations of fundamental constants with precision exceeding human measurements. The visitor wasn't just acknowledging our message, it was correcting and expanding our understanding of physics. More remarkable was what happened to the object itself. Ground-based telescopes observed 3I Atlas physically reconfiguring during transmission panels or structures on its surface, shifting orientation to optimize its signal beam toward Earth. Infrared imaging from the James Webb Space Telescope revealed localized temperature increases in precise regions of the object's structure, thermal signatures consistent with power systems activating. This isn't passive reflection of sunlight or random outgassing. noted Dr. Abraham Loeb in a classified assessment. The object is allocating energy to communication with intention and purpose. By dawn, word had leaked despite government efforts to control the information. Amateur radio operators worldwide had been monitoring the hydrogen line frequency, and the distinctive patterns of the exchange were impossible to miss. Social media erupted with number first contact becoming the highest trending topic globally within hours. The second exchange occurred 48 hours later. This time, 3I Atlas initiated contact, transmitting a complex mathematical sequence that appeared to describe orbital mechanics, not just theoretical principles, but the specific parameters of its trajectory through our solar system. It was demonstrating that its presence was intentional, not a random interstellar encounter. Radio astronomers detected subtle harmonic structures embedded within the transmission, mathematical patterns that appeared to encode three-dimensional geometric information. The visitor wasn't sending simple messages. It was teaching us a communication protocol. Dr. Yuki Tanaka, at Tokyo Institute of Technology, led the international decoding team. The signal structure suggests a layered communication system, she explained in an emergency briefing to UN representatives. The primary carrier contains timing information and data headers, while nested modulations carry the actual content. It's the most efficient encoding system I've ever encountered, with error correction principles we've never conceived. By the fifth exchange on December 12th, the pattern became unmistakable. 3I Atlas was methodically building a foundation for complex information transfer, beginning with universal mathematical principles, progressing to physics, and then introducing concepts without Earth analogues. Most significantly, the Part 1 hive and significantly, object began transmitting during predictable windows, maintaining communication sessions of exactly 11 minutes, a prime number, before ceasing transmission for intervals that could be calculated through mathematical progressions it had previously established. The implications were profound. Not only was 3I Atlas intelligent and responsive, but it appeared to be teaching us a standardized communication protocol, potentially the same system used by other civilizations across the galaxy. We're not just communicating with a visitor, Dr. Martinez told the UN Security Council in a closed session. We're being inducted into a cosmic conversation that may have been ongoing for millions of years. As December progressed, exchanges became more frequent and data-dense. Earth's greatest mathematicians and physicists worked around the clock to process the incoming information, which appeared to contain specifications for technologies beyond human development, but within theoretical reach. By Christmas Day, the undeniable truth had transformed humanity's understanding of its place in the universe. We were not alone, and someone had answered our century of accidental broadcasts with a deliberate, precisely targeted response. The age of cosmic isolation had ended. The question was no longer whether intelligent life existed beyond Earth, but what our relationship with that intelligence would become. By February 2026, a staggering truth emerged from 3I Atlas's transmissions. Humanity had inadvertently stumbled upon the access point to an ancient interstellar communication network spanning significant portions of our galaxy. Dr. Sarah Kim, at MIT's Communication Systems Laboratory, led the team decoding what they called network layer protocols embedded in the visitor's increasingly complex transmissions. The mathematical structures in these signals aren't just language, they're addresses, she explained in testimony, later presented to the National Science Foundation. 3I Atlas is transmitting navigational coordinates for what appears to be an existing network of communication nodes distributed throughout local space. The decrypted coordinates revealed a three-dimensional map of transmission points forming an intricate web throughout a roughly 500 light-year radius from Earth. Some points corresponded with known star systems. Others existed in apparently empty regions of interstellar space, where gravitational lensing effects could naturally amplify signals across vast distances. This wasn't speculation about potential communication methods. It was an operational manual for an actual galactic internet that had existed long before humans discovered radio. The network architecture is ingenious, noted Dr. James Chen in classified documentation. It uses natural cosmic phenomena as infrastructure, gravitational lenses, pulsar timing signals for synchronization, and stellar focal points as natural signal boosters. The system's designers incorporated the galaxy's own structure as their foundation. Most compelling were the temporal markers embedded in the signals. The network appeared to operate on cosmic timescales, with transmission windows determined by stellar positions and pulsar rotations. These natural astronomical clocks provided perfect synchronization across vast distances without requiring artificial timekeeping technology. This isn't just a communication system, Dr. Elena Rodriguez observed in a paper published in the Astrophysical Journal. It's a galactic-scale technology designed to operate reliably across millions of years without maintenance. The beings who created it thought in time scales beyond human comprehension. Analysis of the signal patterns suggested the network had been active for at least 50,000 years, potentially much longer. The technical specifications indicated it was designed to remain functional for millions of years, operating on principles that transcended the lifespans of individual civilizations. The network architecture revealed three distinct communication layers. The beacon layer consisted of automated signal repeaters positioned at strategic points throughout the galaxy. These repeaters broadcast simple carrier signals that allowed new civilizations to discover the network's existence. The message layer carried actual information content, operating on precisely defined frequency ranges with standardized encoding protocols that any technically advanced species could learn to interpret. The coordination layer, most sophisticated and least understood, appeared to manage timing, addressing, and routing across the network, ensuring transmissions reached their intended recipients despite light speed limitations. The most remarkable aspect is the network's inclusivity, Dr. Tanaka noted in a presentation to the International Astronomical Union. It's designed to be discovered and joined by any civilization that achieves basic radio technology. The entry protocols are simple enough for relatively primitive technical societies to implement, while the advanced functions become accessible as a civilization's capabilities grow. 3i Atlas wasn't just revealing the network's existence, it was providing Earth with specifications to build our own. Node. The transmission included detailed technical requirements for constructing what came to be called a galactic beacon, a specialized communication array capable of connecting to the existing network infrastructure. The beacon's specifications pushed the boundaries of existing human technology, but remained theoretically achievable. The design called for arrays of precisely coordinated transmitters, operating across multiple frequency bands, with quantum-stabilized timing systems accurate to femtoseconds. Most intriguingly, the network appeared to incorporate ethical guidelines directly into its technical protocols. Transmission power limits, frequency restrictions near habitable worlds, and modulation techniques designed to be recognizable as artificial rather than natural phenomena, all suggested a communication system designed by beings who understood the responsibility of broadcasting across interstellar distances. This isn't just technology, Dr. Martinez told a closed Senate committee hearing. It's technology with embedded values consideration for biological worlds, sustainable energy usage, and non-interference principles. The network's designers built their ethics into the architecture itself. By March, astronomers had begun detecting faint signals exactly matching the patterns 3i Atlas had described, emanating from precisely the coordinates provided in its transmission. These weren't theoretical nodes. They were active transmission points of an operational network humanity simply hadn't known to look for. SETI researchers who had spent decades searching for artificial signals realized they had been looking with the wrong parameters. The network's communications were designed to appear natural to casual observation, becoming recognizable as artificial only when examined with precise knowledge of the encoding protocols. We've been surrounded by intelligent signals our entire history, Dr. Chen acknowledged in a paper that sent shockwaves through the scientific community. We just didn't know how to distinguish them from background noise. Public reaction to these revelations ranged from wonder to anxiety. Religious leaders grappled with implications of an ancient galactic community predating human civilization. Military strategists worried about potential vulnerabilities in joining a network created by unknown entities with unknown motives. Yet the overwhelming response was curiosity. Humanity had discovered it wasn't alone in the cosmos. We had neighbors who had built communication infrastructure spanning thousands of light years and operating across geological timescales. The question was no longer whether other intelligences existed, but what messages they had been exchanging while Earth developed in isolation, and whether humanity was prepared to join that ancient conversation. As teams worldwide began preliminary designs for Earth's first galactic beacon, the universe had suddenly transformed from a vast emptiness into a neighborhood humming with communication, hidden in plain sight for all of human history, waiting only for us to learn how to listen. While scientists decoded alien communication protocols, anthropologists, psychologists, and social theorists grappled with a far thornier question: how would humanity itself change in response to confirmed extraterrestrial intelligence? Dr. Susan Chen at Stanford's Institute for Applied Psychology documented what she termed cosmic perspective syndrome emerging worldwide. We're witnessing the most profound shift in human self-conception since Copernicus removed Earth from the center of the universe, she noted in the journal Psychological Science. The certainty of other intelligence fundamentally alters our species' understanding of its uniqueness and purpose. Mental health hotlines reported 340% increases in existential anxiety calls during the Posendue first month after public confirmation of 3I Atlas's artificial nature. The conversations followed recognizable patterns: fear about humanity's cosmic insignificance, excitement about potential technological advances, and a peculiar form of cosmic loneliness. The realization that we had never truly been alone, but had believed ourselves to be, for all of recorded history. Religious institutions responded with surprising adaptability. The Vatican issued a statement within 48 hours of confirmation. The discovery of intelligence beyond Earth only magnifies our appreciation of God's infinite creativity. Islamic scholars found support in Quranic verses referring to Allah's creation spanning multiple worlds, while Buddhist leaders interpreted contact as confirmation that consciousness represented a fundamental property of the universe, rather than a purely terrestrial phenomenon. Only certain evangelical Protestant denominations struggled theologically, grappling with questions about souls and salvation for non-human intelligence. Emergency theological conferences convened worldwide, transforming abstract theological exercises into urgent doctrinal necessities. Financial markets experienced what economists termed the contact correction. Defense contractors and aerospace companies saw valuations soar initially, then fluctuate wildly as investors attempted to predict which technologies would become obsolete through alien knowledge transfer. The cryptocurrency space witnessed particular volatility. Bitcoin surged on theories that mathematical currencies might serve as universal exchange mechanisms, while dozens of new contact coins appeared claiming compatibility with theoretical interstellar commerce. We're seeing the market trying to price in a fundamental reshaping of human technological development, noted Dr. James Williams, economist at the London School of Economics. Traditional investment models assume technological progress follows predictable patterns. The possibility of accessing knowledge centuries beyond our development timeline has rendered those models obsolete overnight. Educational institutions reported unprecedented demand for astronomy, physics, and mathematics programs. Community colleges developed cosmic literacy courses, teaching basic principles of interstellar communication. Elementary school teachers noted children incorporated space themes into artwork and creative writing, With remarkable sophistication, many seemed less surprised by contact than adults, as if they had always assumed the universe contained other intelligences. Information warfare intensified across social platforms. Verified sources struggled against conspiracy narratives, claiming the entire contact event represented an elaborate government fabrication. Content moderation algorithms built to identify terrestrial misinformation proved inadequate against speculation about alien intentions. Twitter's trust and safety team developed emergency protocols for extraterrestrial content, the platform's first formal acknowledgement that non-human intelligence might someday participate in global discourse. Predictably, humanity's tribal instincts asserted themselves in response to cosmic revelation. Governments competed to establish primacy in communication efforts, viewing 3i Atlas as an opportunity to gain technological advantages. NATO, Russia, and China each developed independent beacon projects, despite scientific consensus that coordinated global response would prove most effective. The United Nations Security Council convened emergency sessions to establish interstellar communication protocols, but traditional geopolitical divisions hampered progress. Who speaks for Earth? The question moved from philosophical abstraction to urgent practical concern. Yet beneath these institutional responses, subtle psychological shifts were reshaping human consciousness at deeper levels. Astronomical societies reported record attendance at sky-watching events. Night sky photography exploded in popularity. Urban councils faced unprecedented pressure to reduce light pollution not just for scientific reasons, but because citizens wanted to see the stars that potentially hosted other intelligent beings. We're witnessing the emergence of cosmic identity, observed Dr. Elena Rodriguez in the Bulletin of Atomic Scientists. Throughout history, human groups defined themselves against human others. Now, for the first time, humanity is conceiving of itself as a unified entity in contrast to non-human intelligence. Perhaps most profound was the shift in temporal perspective. Corporate planning horizons extended beyond quarterly earnings to decades and centuries. Climate initiatives gained support as people reconsidered Earth's value in a galaxy where habitable worlds might be precious and rare. Archaeological studies received increased funding as humanity sought to understand its own past development in comparison to potentially older civilizations. The contact event is triggering what I call deep time awareness, noted paleontologist Dr. Michael Chen. People are conceptualizing human civilization within geological and astronomical timescales, thinking in terms of thousands or millions of years rather than electoral cycles or human lifespans. Psychological support systems emerged organically as communities processed cosmic revelation. Contact counseling became a recognized specialty, helping individuals integrate understanding of extraterrestrial intelligence into coherent worldviews. Support groups formed in community centers, universities, and online forums, creating spaces where people could express fear, excitement, and wonder without judgment. A generational divide became apparent. While older adults often struggled with fundamental reordering of their cosmic understanding, younger generations adapted with remarkable flexibility. Children born after confirmation would grow up, never knowing a human-centric universe. Their baseline assumption would always be that intelligence represented a cosmic phenomenon rather than a terrestrial exception. The universe had not physically changed. The stars remained at the same distances, and daily human concerns continued unaltered. Yet everything had transformed in the realm of meaning. Humanity had discovered it was participating in a story far larger and older than its own history, a narrative of intelligence emerging across the galaxy over billions of years, communicating across vast distances through technology designed to operate on astronomical timescales. In this new understanding, Earth wasn't the center of creation, but neither was it cosmic backwater. We were latecomers to an ancient conversation, but we had been invited to join. By April 2026, the international scientific community reached a sobering conclusion. 3I Atlas was likely not a standalone visitor, but part of a coordinated surveillance and contact operation involving dozens of interstellar objects that had been entering our solar system with increasing frequency since 2017. The statistical distribution of these objects defies natural explanation. Dr. Alan Fitzsimmons confirmed in a peer-reviewed analysis published in Nature Astronomy. Their trajectories converge from a narrow 15-degree cone centered on the constellation Lyra. The probability of this alignment occurring by chance is approximately 1 in 57 million. Equally troubling was the object's precision targeting. Their perihelion closest approach points to the Sun, clustered within a narrow range between 0.8 and 1.2 astronomical units, threading the needle of Earth's orbital zone while maintaining safe distances from our planet. The calculated probability of natural interstellar objects accidentally converging on Earth's specific orbital region was vanishingly small. These aren't random wanderers, Dr. Sarah Martinez testified before a classified congressional hearing. They're precisely directed probes with calculated trajectories optimized for observing Earth, while being observable from Earth-based telescopes. Very long baseline interferometry confirmed that several objects, they were making subtle course corrections, minor velocity changes that couldn't be explained by gravitational perturbations or radiation pressure alone. The adjustments appeared deliberately engineered to maintain optimal observation geometry. More unsettling was their apparent coordination. As multiple objects passed through the inner solar system, their radio emissions showed temporal correlations that defied coincidental explanation. Brief synchronized transmissions occurred simultaneously across objects separated by millions of kilometers, suggesting real-time communication between what now appeared to be components of a distributed observation network. Light curve analysis revealed these objects displayed geometries inconsistent with natural formation processes. Where 3I Atlas resembled a thin rotating panel, subsequent visitors showed even more exotic configurations. The object designated 4I produced brightness variations, suggesting a needle-like structure, with an aspect ratio approaching 20:1 longer and thinner than any known natural object in the solar system. 5I appeared to be a tumbling shard with properties suggesting partial fragmentation, while 6I generated patterns consistent with a flexible, sheet-like structure that rippled as it rotated through space. These shapes violate principles of collision physics, noted Dr. Elena Vasquez in the Astrophysical Journal. Natural fragments follow predictable patterns based on material strength and impact dynamics. But we're observing geometries that appear deliberately engineered for specific functions: minimal mass, maximum surface area, and controlled attitude dynamics. Radio emissions provided perhaps the most compelling evidence of artificial design. Each object broadcast narrowband signals near the hydrogen line frequency, but with different modulation patterns, frequency offsets, and temporal characteristics that suggested distinct functional roles within a coordinated communication system. 3I Atlas maintained its steady carrier tone at 1,420.4 MHz. 4I transmitted at 1,420.6 MHz with subtle amplitude modulation patterns. 5I produced brief bursts across multiple frequencies in the waterhole spectrum, while 6I generated complex signals with apparent information content encoded in both frequency and timing variations. This diversity rules out natural phenomena like plasma interactions or maser emissions, which would produce similar characteristics across objects with similar compositions. Dr. James Chen explained in an emergency briefing to NASA administrators. These visitors are operating as a coordinated fleet, each component fulfilling specific roles in a larger mission architecture. When astronomers reconstructed potential launch windows based on the object's arrival timing and assumed travel velocities of 10–20% light speed, they discovered correlations with Earth's broadcast history that appeared non-random. 3i Atlas's arrival timeline aligned perfectly with human television broadcasting peaks in the early 1970 seconds, while subsequent objects corresponded to military radar installation periods and satellite communication expansion. This suggested a civilization within approximately 50 light-years had been monitoring Earth's electromagnetic emissions for decades, dispatching increasingly sophisticated probes in response to our technological development. By June 2026, the catalogue contained 27 confirmed interstellar objects with unusual characteristics, with dozens more candidates awaiting confirmation. This wasn't a one-time event, but an ongoing operation of increasing scope and sophistication. Most concerning to military strategists was the visitors' apparent capability for real-time tactical coordination. Brief, encrypted, appearing transmissions passed between objects during close approach phases, suggesting command and control functions rather than passive observation. The objects demonstrated awareness of each other's positions and activities, operating as components in a unified system rather than independent probes. "We're not dealing with random cosmic encounters," concluded a classified Pentagon assessment. "We're witnessing a deliberate, coordinated surveillance operation conducted by intelligence with technological capabilities far exceeding our own." Yet paradoxically, this surveillance operation made no attempt at concealment. The visitors broadcast their presence on frequencies humans had been monitoring for decades, positioned themselves where Earth-based telescopes could easily detect them, and responded immediately to communication attempts. This suggested either supreme confidence that humanity posed no threat, or deliberate transparency intended to establish non-hostile intentions. Either interpretation indicated intelligence operating according to strategic principles humans could potentially understand, despite vast technological disparities. The discovery that 3i Atlas represented just one component in a larger contact mission carried profound implications. Earth wasn't experiencing a random encounter with a lone messenger, but systematic evaluation by a civilization capable of coordinating multiple spacecraft across interstellar distances. The scope of the operation suggested resources and organizational complexity far beyond current human capabilities, a sobering reminder of the potential technological gap between our civilization and whoever had sent these sophisticated ambassadors to study our world. Most significantly, the coordinated nature of the mission suggested purpose and intention rather than random exploration. Something had attracted sustained attention to our unremarkable yellow star, most likely the accidental radio broadcasts that had been announcing our technological development to nearby stellar systems for nearly a century. And now, that attention had manifested as a fleet of interstellar visitors, studying our world with technologies we could barely comprehend, while offering us entry into a galactic community whose existence we had never suspected. The controlled thermal management capabilities of 3i Atlas defied conventional physics. As the object traversed different heliocentric distances, its temperature didn't follow the inverse square law governing normal solar system bodies. Instead, it maintained thermal plateaus regions where surface temperature remained constant despite changing solar irradiation patterns. The thermal behavior suggests active management systems rather than passive response to environmental conditions, noted Dr. Sarah Kim in a classified assessment for the Planetary Defense Coordination Office. The object appears to be redistributing energy throughout its structure, with efficiencies exceeding any human technology. Infrared mapping from the James Webb Space Telescope revealed localized hotspots that activated during radio transmission events. Thermal signatures, consistent with power systems allocating energy specifically for communication, rather than random temperature fluctuations from outgassing or solar heating. Most troubling were the temperature differentials observed across the object's surface. Natural bodies in space achieve relative thermal equilibrium based on rotation and solar exposure. 3i Atlas maintained precise temperature gradients that persisted despite rotational cycles, suggesting internal thermal regulation systems capable of managing heat distribution across its entire structure. This isn't passive response to solar heating, Dr. James Chen explained in testimony before the National Science Foundation. The object is actively controlling its thermal signature for reasons that likely include both operational requirements and communication functions. The thermal control capabilities extended beyond self-regulation. During close observation periods, Webb detected brief, intense thermal pulses from specific regions of 3I Atlas's surface, millisecond temperature spikes, reaching several hundred Kelvin above baseline, occurring in patterns that correlated with its radio transmission sequences. These thermal pulses appeared deliberately synchronized with communication events, suggesting the visitor was using coordinated electromagnetic and thermal signatures as complementary communication channels. The precision timing of these thermal events required control systems operating at nanosecond scales technology, well beyond current human capabilities. Equally anomalous was 3I Atlas's interaction with the solar wind. Natural objects in space develop characteristic plasma sheaths as charged particles from the sun interact with their surfaces and any outgassing materials. The visitor displayed plasma formations that defied conventional magnetohydrodynamic models, structured patterns, suggesting active manipulation of charged particles rather than passive interaction. The plasma formations show characteristics of controlled electromagnetic fields, observed Dr. Elena Vasquez at the Atacama Large Millimeter Array. The object appears to be using the solar wind itself as both an energy source and a sensing medium, harvesting particles and using field interactions to monitor its surrounding environment. These observations pointed toward propulsion capabilities that transcended conventional reaction mechanics. The object's non-gravitational accelerations were subtle but unmistakable, course corrections too precisely directed to result from random outgassing. Yet no visible exhaust plumes or reaction mass appeared in even the most sensitive observations. The only reasonable explanation involved field propulsion, the manipulation of electromagnetic forces to generate thrust without expelling physical reaction mass. Such technology remains theoretical in human physics, limited to conceptual proposals rather than practical implementation. More disturbing still was 3I Atlas's apparent awareness of Earth-based observation attempts. When the Goldstone Deep Space Network directed radar pulses toward the object for imaging purposes, it responded by slightly altering its rotational characteristics, presenting different aspects of its structure toward Earth. This suggested not just passive reaction to external stimuli, but intelligent response to being observed behavior, consistent with a probe conducting its own surveillance while aware of human attempts to study it. The object demonstrates situational awareness, noted a classified assessment from the place. National Reconnaissance Office. It's not just passing through our solar system, it's studying us while we study it, modifying its behavior based on our observation techniques. The Hubble Space Telescope captured another inexplicable phenomenon during close approach monitoring. Brief, microsecond flashes of coherent light emanated from 3I Atlas at precisely regular intervals, optical pulses in the visible and near-infrared spectrum that appeared artificially generated rather than reflected sunlight. These optical pulses followed mathematical patterns matching those observed in the object's radio emissions, suggesting coordinated communication across multiple electromagnetic bands. The pulses demonstrated color, purity, and temporal precision impossible to achieve through natural processes, requiring optical systems capable of generating coherent light with femtosecond timing accuracy. Advanced spectroscopic analysis revealed another layer of impossibility. The object's surface contained trace elements, arranged in patterns, inconsistent with natural formation processes, rare earth metals distributed in geometries, suggesting deliberate doping for specific electromagnetic properties. These patterns weren't random accumulations but organized structures consistent with engineered metamaterials designed to interact with electromagnetic fields in precise ways. The surface composition shows hallmarks of atomic-scale engineering, Dr. Abraham Loeb concluded after analyzing data from multiple observatories. The material structures appear designed to interact with radiation across multiple wavelengths for purposes that likely include energy collection, sensing, and communication. Perhaps most baffling was the object's mass-to-volume ratio, which contradicted all known material science principles. Based on radar cross-section measurements and observed gravitational interactions, 3I Atlas possessed density characteristics that couldn't be achieved with any known materials too light for its apparent structural integrity, yet maintaining rigidity during high-velocity maneuvers that would tear apart conventional objects. We're observing either hollow structures with incredible strength-to-weight ratios or materials with internal architectures beyond our current engineering capabilities, noted Dr. James Williams in a presentation to the American Physical Society. The object's structural properties suggest materials science centuries beyond our present understanding. These observations collectively painted a picture of technology so advanced it approached Arthur C. Clarke's famous dictum that any sufficiently advanced technology is indistinguishable from magic. 3I Atlas wasn't violating physics, it was operating according to physical principles humans understood in theory but couldn't yet implement in practice. The visitor displayed energy management capabilities, materials science, propulsion systems, and communication technologies that represented not incremental improvements over human capabilities, but quantum leaps beyond our engineering limits. It was as if Stone Age humans encountered a modern aircraft carrier, recognizably technological, but operating according to principles beyond their conceptual framework. Yet this advanced technology was approaching Earth, not with overwhelming force or incomprehensible displays of power, but with mathematical patterns specifically designed to be recognized and interpreted by a technological civilization at precisely our stage of development. The message was clear. 3I Atlas represented an intelligence vastly more advanced than humanity, yet deliberately communicating in ways we could understand, a technological gulf bridged by the universal languages of mathematics and physics. The moment humanity seriously contemplated building an interstellar beacon, civilization began transforming in ways no one could have predicted. The beacon specifications transmitted by 3I Atlas pushed the boundaries of human manufacturing capabilities without exceeding them, a technological challenge precisely calibrated to our development level. Engineering teams worldwide mobilized for rapid prototyping. The plans called for ultra-thin metamaterials engineered at nanoscale to form primary transmission elements. Low-noise oscillators locked to quantum-stabilized atomic frequency standards would provide the stable references needed for galaxy-wide communication. The most challenging requirement was coordination. Thousands of individual transmitters distributed across hundreds of kilometers, all operating in perfect synchronization. This timing precision, nanosecond accuracy, maintained over interplanetary distances, demanded revolutionary advances in quantum timekeeping and distributed control systems. Hybrid radar laser systems emerged as the foundation technology. By combining radio transmissions with precisely timed optical pulses, Earth's beacon could achieve the bandwidth and power requirements specified in the visitor's instructions. The dual-mode approach provided redundancy against natural interference. If one system failed, the other maintained contact with the network. But each technological breakthrough carried dual-use implications that reshaped geopolitics. The same precise timing systems required for interstellar communication could guide intercontinental ballistic missiles with unprecedented accuracy. The high-power transmitter arrays might potentially interfere with satellite operations or even function as directed energy weapons. Planetary defense advocates successfully argued for transparency protocols, allowing international monitoring of beacon construction and testing. The technology was simply too powerful to develop in secrecy. Legal frameworks struggled to adapt to this new reality. The Outer Space Treaty of 1967 governed activities beyond Earth's atmosphere, but said nothing about communicating with alien civilizations. The Liability Convention of 1972 addressed damage from space objects, but couldn't anticipate disputes over interstellar messaging rights. Legal scholars worldwide began drafting model legislation for contact governance, international protocols for extraterrestrial communication that borrowed heavily from existing arms control and environmental protection frameworks. The question of who speaks for Earth transformed from philosophical musing to urgent policy challenge. With 3i Atlas's beacon specifications in hand, multiple nations and organizations claimed authority to build and operate humanity's node in the galactic network. NASA proposed an international consortium modeled on the International Space Station Partnership. China announced plans for an independent beacon system. Private corporations submitted proposals arguing that commercial competition would accelerate development. Data rights emerged as perhaps the most contentious issue. Would the beacon's transmissions constitute public information available to all humanity? Or would the nations and organizations that built the system control access to interstellar communication? The precedent established with Earth's first beacon would likely determine communication governance for generations. Economic ripples spread through every sector. Rare earth elements required for beacon construction triggered commodity price spikes that persisted for months. Lithium, already essential for battery technology, acquired new strategic importance as engineers recognized its role in quantum frequency standards. But the most profound economic shift was psychological investment horizons, expanded from quarters and years to decades and centuries. Companies began planning for market opportunities that might not materialize until their founders' great-grandchildren made business decisions. Cryptocurrency markets spawned hundreds of speculative, galactic coins designed for theoretical interstellar commerce. Most were obvious scams, but some represented serious attempts to create communication protocols that could function across species barriers. The mathematical requirements for galaxy-wide consensus mechanisms pushed blockchain technology in unprecedented directions. Religious institutions grappled with humanity's changing cosmological status. Were humans still made in God's image if we shared the galaxy with other intelligent beings? Did moral obligations extend to civilizations we had never met but might soon join? Theological seminaries established departments of astroethics and interspecies communication almost overnight. Educational systems experienced unprecedented demand for physics, mathematics, and engineering programs. Students who had never shown interest in technical subjects suddenly wanted to understand the science behind interstellar communication. Community colleges offered beacon literacy, courses teaching basic concepts needed to participate in humanity's cosmic conversation. Environmental considerations complicated beacon planning. The transmission arrays would require enormous amounts of electricity, potentially gigawatts, during peak operation. Carbon-neutral power sourcing became essential to avoid worsening Earth's climate problems while reaching for the stars. Solar farms and fusion research received new investment as the environmental movement allied with space communication advocates. Ground-based transmission systems raised concerns about electromagnetic effects on wildlife. Birds, whales, and other animals that navigated using Earth's magnetic field might be disrupted by powerful radio emissions. Careful site selection and transmission protocols would be needed to minimize ecological impact. The cislunar region became humanity's newest frontier for beacon development. The far side of the Moon offered natural radio shielding from Earth's interference, making it ideal for sensitive receiving equipment. Near-Earth asteroids could provide construction materials without the environmental costs of Earth-based mining. International cooperation emerged as both necessity and opportunity. No single nation possessed all the resources needed for rapid beacon construction. Successful projects required sharing technology, funding, and expertise, across traditional political boundaries. The beacon became a catalyst for global collaboration that had proven elusive for purely terrestrial challenges, but cooperation carried its own risks. Shared beacon systems would need governance structures that could survive political changes and international conflicts. What would happen if participating nations disagreed about message, content, or transmission priorities? How would humanity resolve disputes when the consequences might affect our standing in a galactic community? As construction timelines compressed and launch dates approached, humanity found itself transforming not just its technology but its identity. We were no longer an isolated species shouting into the void. We were preparing to become citizens of a galaxy-spanning civilization whose true scope we were only beginning to understand. The most profound second-order effects extended far beyond the beacon itself. Every aspect of human society, from education and economics to governance and philosophy, began adapting to the reality that we shared the universe with intelligences whose capabilities might dwarf our own. The very process of preparing to join the galactic conversation was fundamentally reshaping civilization itself. 2 years after first radio exchange with 3i Atlas, humanity stood at a crossroads that would define our species' trajectory for millennia to come. The visitor had departed our solar system in early 2027, accelerating along its hyperbolic trajectory toward destinations unknown. But its message remained encoded in our databases and collective memory, a blueprint for joining a galactic community we never imagined existed. The decision before us seemed deceptively simple: build the beacon or remain silent. Yet the implications of each choice reached into every aspect of human civilization. 3 scenarios dominated policy discussions across the world's capitals and academic institutions. The conservative path advocated maintaining listening posts and expanding passive SETI capabilities while avoiding active transmission that might attract unwanted attention. Proponents argued we needed decades or centuries to better understand the galactic community before announcing our presence. Better to observe quietly, learning about potential neighbors before revealing our location and capabilities. This approach carried obvious appeal. It was safe, reversible, and allowed humanity to develop on our own timeline. We could continue advancing technology, expanding throughout the solar system, and building economic and social foundations needed to engage with more advanced civilizations as equals rather than supplicants. But critics pointed out the costs of isolation. The beacon specifications provided by 3i Atlas represented technology centuries ahead of human development. Refusing to engage might delay our advancement indefinitely, leaving us permanently behind civilizations that had been communicating for millennia. The participatory path proposed building a modest, carefully controlled beacon system that could be activated or deactivated based on humanity's collective decision-making. This middle course would establish our capability to join the galactic network without immediately committing to active participation. The technical requirements were significant, but achievable. A distributed array of transmitters, coordinated by quantum timing systems, positioned in space to avoid interference with Earth's biosphere. The beacon would operate at minimum power levels initially, announcing our presence but not overwhelming nearby communication nodes with inexperienced transmissions. Governance structures would ensure no single nation or organization controlled humanity's voice in galactic affairs. Message content would require international approval through expanded UN frameworks. Transmission schedules would balance scientific exploration with diplomatic caution. The ambitious path called for full commitment to interstellar communication within a decade. Proponents argued that 3i Atlas's beacon specifications included time-sensitive coordination requirements. If humanity wanted to join the galactic network effectively, we needed to move quickly while the visitor's message remained current and relevant. This approach promised rapid technological advancement and immediate access to whatever knowledge the galactic community was willing to share. Early participation in interstellar communication might provide humanity with scientific and technological advantages that could solve our most pressing problems: climate change, resource depletion, and the challenges of expanding beyond Earth. But the risks were enormous. Full participation would make Earth permanently visible to any intelligence monitoring the network. We would be committed to relationships and obligations we couldn't fully understand. Withdrawal once we had joined might prove impossible or carry severe consequences. The debate transcended traditional political boundaries. Progressive environmentalists found themselves aligned with conservative military strategists in favoring caution. Libertarian technologists allied with international diplomats in supporting measured engagement. The cosmic perspective had scrambled conventional political categories. Public opinion remained divided, but engaged. Polling consistently showed majority support for some form of beacon construction, with significant variations based on specific proposals and implementation timelines. The most popular approach combined elements of all three scenarios: building beacon capability quickly, but activating it gradually, with extensive safeguards and international oversight. The Galileo project, originally conceived to search for extraterrestrial technosignatures, evolved into a standing program for interstellar contact preparation. Its expanded mission included monitoring for additional visitors, analyzing 3i Atlas's beacon specifications, and developing scientific foundations for future contact scenarios. Funding mechanisms emerged from unexpected sources. Tech billionaires who had previously focused on Earth orbit ventures redirected investment toward interstellar communication. Nations that had never participated in space programs began contributing to beacon development consortia. The distributed nature of the required technology allowed smaller countries to make meaningful contributions through specialized manufacturing or research. Legal frameworks continued evolving through international negotiations. The Outer Space Treaty's restrictions on national appropriation of celestial bodies were extended to cover interstellar communication nodes. New protocols governed sharing alien technology and distributing benefits from galactic participation. The question of institutional stewardship became critical. Beacon systems designed to operate for centuries required governance structures that could survive political changes, economic upheavals, and social transformations. The precedent of maintaining continuity across generations would determine whether humanity could be a reliable member of any galactic community. Scientific preparations accelerated regardless of policy decisions. Radio telescopes continued monitoring for additional visitors and attempting to detect the broader galactic communication network described in 3i Atlas's message. Gravitational lensing experiments tested whether stellar focal lines could amplify signals across interstellar distances as the visitor's specifications suggested. As humanity's choice crystallized around a fundamental question of identity: are we explorers or preservers? Do we define ourselves by willingness to reach into the unknown, or by commitment to protecting what we have already achieved? The answer reflected both impulses. Humanity would build the beacon, but carefully. We would join the galactic community, but on terms that preserved our autonomy and protected our homeworld. The night sky looked different now. The points of light that once seemed distant and lifeless were revealed as potential homes to intelligences whose messages might already be traveling toward Earth at the speed of light. The cosmos had become a neighborhood vast beyond comprehension, but no longer empty. In the end, perhaps this was 3i Atlas's greatest gift: not technology to join a galactic civilization, but knowledge that we had never truly been alone. On a warm July evening in 2027, 2 years after 3 Atlas's first detection, Dr. Elena Vasquez stood atop Chile's Cerro Pachón mountain, watching the constellation Microscopium rise above the southern horizon. Somewhere in that patch of sky, now billions of kilometers distant, humanity's first confirmed interstellar communicator continued its ancient journey through the galaxy, unaware of how profoundly it had transformed the civilization it briefly encountered. "It's still out there," she said to her graduate student, "traveling just as it has for perhaps billions of years, but we will never be the same." The cosmic perspective that 3i Atlas had forced upon humanity was still integrating into our collective consciousness. Our species had witnessed a profound compression of historical timescale. We had gone from wondering if intelligent life existed elsewhere to confirming its reality in less than 2 years. This was like the Wright brothers witnessing the moon landing, or ancient alchemists directly observing nuclear fusion. The psychological, philosophical, and spiritual dimensions of this shock continued reverberating through human society. We learned that we are not unique, wrote philosopher Dr. Amir Rahman in his best-selling book, Strangers Among Stars. Yet paradoxically, this revelation has made us more aware of what is uniquely human. We cannot define ourselves in opposition to non-human intelligence, but must instead understand what distinguishes us among many forms of consciousness. Anthropologists documented emergence of what they termed cosmic identity, people increasingly defining themselves not just by nationality, ethnicity, or religion, but by their relationship to a universe now known to contain other minds. I am human, but I am also a citizen of a galaxy where we are not alone, became a common sentiment in interviews and surveys. Perhaps most striking was the generational divide in adapting to this new reality. Adults struggled with incorporating alien intelligence into worldviews formed before contact. Young children, however, seemed to absorb the news with remarkable equanimity. To them, a universe containing multiple forms of intelligence seemed natural and expected. Educational researchers at Stanford documented this phenomenon through analysis of children's artwork and creative writing. The children aren't shocked by the idea of intelligent aliens, noted lead researcher Dr. Susan Chen. Many seem to have suspected it all along. What surprises them is that adults are surprised. This perspective shift manifested in unexpected ways. Climate scientists reported increased support for long-term sustainability initiatives, not because of immediate environmental concerns, but because humanity increasingly saw itself as a potentially permanent participant in galactic affairs. We're no longer building just for ourselves, or even our grandchildren, noted UN climate envoy Dr. James Chen. We're establishing the foundation for humanity's place in a multi-galactic civilization. That requires thinking in terms of millennia, not decades. Astronomers working with the James Webb Space Telescope reported subtle but significant changes in how they interpreted exoplanet data. Before 3i Atlas, we thought of habitable worlds as interesting but abstract scientific targets, explained Dr. Yuki Tanaka. Now, when we observe a potentially life-supporting planet, we can't help wondering if it hosts a civilization already participating in the network 3i Atlas revealed. We're no longer just studying planets, we're searching for neighbors. Religious leaders continued theological recalibration. The Vatican Observatory hosted an unprecedented interfaith conference titled Many Worlds, Many Minds, One Creation, that brought together Catholic theologians, Buddhist scholars, Islamic astronomers, Hindu philosophers, and Jewish rabbis to discuss implications of confirmed extraterrestrial intelligence. The question isn't whether our faiths can accommodate non-human intelligence, stated Vatican astronomer Father Giovanni Rossi, but how our understanding of divinity expands when we recognize we are not alone in creation's vast tapestry. Philosophers of consciousness found their field revolutionized almost overnight. The possibility of studying non-human intelligence that evolved independently from Earth life promised insights into whether consciousness follows universal patterns or divergent paths. Theoretical frameworks were developed for eventual comparative studies between human and alien cognition. We may finally be able to distinguish between aspects of consciousness that are contingent upon our specific evolutionary path and those that represent universal properties of any sufficiently complex cognitive system, wrote Dr. Sarah Martinez in the journal Philosophical Transactions. Even perceptions of time underwent transformation. Archaeological funding increased dramatically as humanity sought deeper understanding of its own past development. We're preparing to introduce ourselves to civilizations potentially millions of years older than our own, explained Dr. Michael Chen, director of the Global Heritage Initiative. We need to understand our complete story, not just recorded history, but our evolution from the first hominids to modern humans. Memorials and time capsules gained new significance as potential messages to the distant future. The Svalbard Global Seed Vault expanded its mission beyond preserving biodiversity to include comprehensive records of human knowledge and achievement. We're now thinking in geological timescales, noted its director. These archives might be consulted by our descendants thousands of years from now, as they maintain humanity's place in galactic dialogues. Psychologists documented emergence of what some called deep time, awareness, a conscious extension of temporal perspective beyond individual lifespans to encompass civilizational timeframes. People began conceptualizing their actions within cosmic history rather than personal biography. Community surveys showed increasing concern for humanity's development path over centuries rather than immediate concerns. Corporate strategic planning underwent similar transformation. Major technology companies established millennial impact divisions, tasked with projecting consequences of business decisions across centuries rather than fiscal quarters. Investment patterns shifted toward infrastructure with multi-generational benefits rather than short-term returns. The most profound philosophical shift involved purpose. Pre-contact humanity had struggled with existential questions about cosmic significance. Post-contact humanity increasingly viewed itself as part of an ongoing conversation among intelligent species, a conversation that had been occurring long before humans evolved and would continue long after our current civilization, transformed into something unrecognizable to modern eyes. We now know we are not alone, and we never were, wrote Dr. Elena Vasquez in her field journal that night on Cerro Pachon. The stars above me potentially host thousands of civilizations at various stages of development. Some may have been communicating for millions of years. Others may be where we were a century ago, just beginning to send their first radio whispers into the dark. The universe is not silent. It has been speaking all along. We simply lack the perspective to hear it. As 3-4 Atlas receded into interstellar space in late 2026, the scientific community confronted a sobering reality. Our most profound visitor had never fully revealed itself. Despite months of intensive observation using humanity's most advanced instruments, fundamental questions remained unanswered. Was 3I Atlas a fully autonomous probe? Did it represent a living civilization, or the technological remnant of one long extinct? Were its messages designed specifically for Earth, or standard protocols deployed whenever it encountered technological worlds? This deliberate ambiguity appeared central to the visitor's mission. The messenger had shared incredibly sophisticated technical knowledge, while revealing almost nothing about its creators. We were given instructions to join a galactic conversation without being told who else was speaking. The silence regarding its origins may be the most important message of all, noted Dr. James Chen in a classified assessment for NASA. 3I Atlas provided everything we need to connect with the galactic network, while withholding anything that might create dependency or worship. We weren't given gifts, we were given tools, with the clear expectation that we would learn to use them ourselves. The visitor's communication strategy reflected sophisticated understanding of first contact psychology. By focusing exclusively on technical specifications rather than cultural exchange, 3I Atlas sidestepped potential incompatibilities between alien and human thought patterns. The mathematical foundations established universal ground on which species with potentially radically different evolutionary histories could build shared understanding. This approach brilliantly avoids the trap of anthropomorphizing alien intelligence, wrote Dr. Elena Vasquez in the Journal of Astrobiology. If 3I Atlas had attempted to explain its civilization's history, philosophy, or biology, we would inevitably have misinterpreted these concepts through human cultural frameworks. By restricting communication to physics and mathematics, It established genuine connection without misunderstanding. Most striking was the visitor's careful calibration of technological disclosure. The beacon specifications pushed humanity's engineering capabilities without exceeding them. The quantum timing systems, metamaterial arrays, and error correction protocols represented advances we might have developed over centuries. Yet the design relied exclusively on materials and manufacturing techniques that 21st century Earth could implement. It's like giving medieval craftsmen blueprints for mechanical watches rather than smartphones, explained Dr. Yuki Tanaka. The plans would transform their technology without paralyzing them with capabilities they couldn't possibly reproduce or maintain. The social engineering embedded in this approach became increasingly apparent. By providing achievable yet challenging specifications, 3i Atlas created incentives for international cooperation without forcing it. No single nation could construct the beacon alone, yet the benefits of participation were too significant to ignore. The visitor had subtly nudged humanity toward collaboration rather than competition. We're looking at an object that understood not just our physics, but our politics, noted UN Secretary General Amara Okafor in a closed session of the Security Council. It crafted a message that navigates our geopolitical landscape as precisely as it navigates interstellar space. 3. iAtlas's legacy extended beyond its technical message to fundamentally reshape humanity's understanding of communication itself. The layered encoding methods, mathematical primitives building toward complex concepts through sequential scaffolding, established entirely new paradigms for information exchange across significant knowledge gaps. We're implementing these protocols in diplomatic contexts where mutual comprehension can't be assumed, explained Dr. Sarah Martinez, lead linguist at the UN Translation Division. The 3i Atlas communication architecture is already transforming how we approach human language barriers. Most profoundly, the visitor's message contained what appeared to be deliberate conservation ethics. The beacon specifications incorporated stringent safeguards against electromagnetic pollution that might interfere with biological processes on inhabited worlds. The transmission protocols included periodic listening phases that prevented any single participant from dominating the network. These aren't just technical specifications, they're the constitution for a sustainable galactic communication infrastructure, observed Dr. Amir Rahman. The system is designed to preserve biological and cultural diversity while enabling information exchange. It represents ethics embedded in engineering. For all that 3.4 Atlas revealed, what it withheld created the most enduring questions. Despite continuous monitoring during its solar system passage, the visitor maintained strategic silence about the number, location, or nature of other intelligences participating in the galactic network. It provided coordinates for communication nodes, but no information about who established them or when. This is either extraordinary diplomacy or extraordinary caution, Dr. Chen noted in his assessment. By withholding specific information about other civilizations, 3i Atlas allows humanity to join the network without preconceptions or prejudices about potential communication partners. Historians increasingly viewed 3i Atlas as implementing lessons learned from humanity's own colonial encounters, where technological disparities often led to cultural destruction. By providing only communication capabilities rather than cultural or technological dominance, the visitor enabled contact while preserving autonomy. It's like being invited to a conversation rather than conquered, explained Dr. Michael Chen, professor of contact anthropology at Beijing University. We're entering the galactic community as participants, not subjects. As Earth began preliminary beacon construction, 3i Atlas's most significant legacy became clear. It had fundamentally reframed humanity's cosmic narrative. Pre-contact humanity had viewed itself as either alone in the universe or potentially threatened by alien intelligence. Post-contact humanity increasingly understood itself as a latecomer to an ancient conversation, a conversation conducted with exquisite restraint and respect for developmental autonomy. The great silence was never silence. Dr. Elena Vasquez wrote in the final entry of her observation journal, "It was patience. The galaxy has been speaking all along, but carefully, ethically, waiting for each intelligence to develop the capacity to join the dialogue on its own terms, in its own time. 3i Atlas wasn't just a messenger," she concluded. "It was a teacher, demonstrating through its very restraint how advanced civilizations communicate across the developmental gaps that separate them. The wisdom lies not just in what was said, but in what was deliberately left unsaid." As humanity prepared to broadcast its first official transmission to the galactic network, this legacy of thoughtful silence informed our own message. We had learned not just how to speak to the stars, but when to listen. On the 14th of June 2029, humanity prepared to officially join the galactic conversation. 4 years of intensive engineering had transformed 3i Atlas's technical specifications into the International Beacon Array, an intricate network of transmission and receiving stations, distributed across Earth's surface, lunar orbit, and the Lagrange points. Though not yet at full capacity, the system had reached minimum operational requirements for network synchronization. Dawn broke over the primary control facility in New Zealand's Mackenzie Basin, chosen for its radio quietness and symbolic position as one of the last major landmasses settled by humans, a reminder of our species' journey from African origins to global civilization. The facility's architecture reflected its historic purpose, a circular structure reminiscent of ancient astronomical observatories, but built with metamaterials that channeled electromagnetic energy with unprecedented precision. Dr. Elena Vasquez, now director of the International Communication Consortium, addressed the global audience, watching this milestone through a coordinated broadcast, reaching an estimated 5.9 billion people. Today we take our place in a conversation that may have been ongoing for millions of years. Our beacon connects us to a network whose full extent we can only imagine. We activate this system not knowing who might receive our transmission or when they might respond. But we proceed with the understanding that this step transforms humanity from accidental broadcasters to intentional participants in galactic dialogue. The transmission protocol had been established through years of international negotiation. Unlike 3i Atlas's purely mathematical communications, Earth's first official message would include limited cultural content, a carefully designed self-portrait of humanity that balanced honesty with aspiration. The message structure reflected both human creativity and alien instruction. Its foundation was the mathematical framework provided by 3i Atlas prime number sequences, physical constants, and timing protocols that would identify the transmission as participating in the galactic network. But the content represented human consensus about what aspects of our civilization deserved introduction to the cosmos. The core transmission, encrypted in the carrier wave using modulation techniques specified by 3i Atlas, contained 5 elements. First came Earth's cosmic address, our solar system's position relative to galactic landmarks, the physical characteristics of our sun and planets, and our planet's atmospheric composition. This established context for any intelligence receiving the message. Second came a timeline of terrestrial evolution, from single-celled organisms to multicellular life, to the emergence of human civilization. This historical narrative acknowledged our youth as a technological species while demonstrating awareness of our biological heritage. The third section presented human biological diversity through genetic data rather than visual images that might privilege particular physical appearances. This genomic portrait emphasized both our unity as a species and our adaptation to different environments. Fourth came a cultural sampler mathematical theorems discovered independently across human civilizations, musical patterns representing diverse cultural traditions, and linguistic structures from major language families. These demonstrated the multiple paths through which humans had explored universal concepts. The final section contained Earth's questions, carefully formulated inquiries about the network, its participants, and its purpose. These questions acknowledge the limits of our understanding while expressing willingness to learn. Notable for its absence was any detailed information about Earth's defenses, resource concentrations, or technological vulnerabilities. The debate over disclosure had been extensive, but the final consensus erred toward prudent restraint. We would introduce ourselves honestly, without naively assuming universal benevolence. At precisely 11:43 UTC, Dr. Vasquez initiated the transmission sequence. Power systems worldwide had been reinforced for this moment, channeling unprecedented energy into the distributed array. The carrier wave stabilized at exactly 1,420.4, 05751 MHz, the precise frequency specified in 3I Atlas's instructions, mathematically related to hydrogen's fundamental atomic transition. For 11 minutes, a prime number interval, suggested by 3I Atlas's own communication pattern, Earth broadcast its introduction to the stars. Quantum-stabilized timing systems maintained perfect synchronization across the global array, creating a coherent signal that would remain detectable across interstellar distances. Then, following the protocol established by our visitor, the system switched to receiving mode. Now we would listen for days, years, perhaps decades for any response from the network we had just joined. In control centers worldwide, scientists and dignitaries waited in contemplative silence. No one expected immediate reply. The nearest network node identified in 3I Atlas's specifications was approximately 32 light-years distant. Any response would take at minimum 64 years to complete the round trip, a cosmic conversation that would span generations. We have entered the realm of deep-time communication, Dr. Amir Rahman observed to the assembled observers. Our children or grandchildren may receive the first responses to the message we've sent today. We're not just communicating across space, but across time, placing our words into a conversation that may have been unfolding since before humans walked the earth. As the transmission concluded, a subtle transformation seemed to sweep through the control room and beyond, captured by cameras broadcasting worldwide. It wasn't disappointment at the lack of immediate response, but rather a dawning recognition of the timescale of the enterprise humanity had just undertaken. We've initiated something that transcends our individual lives, Dr. Yuki Tanaka noted in her observation journal. For the first time in human history, we've consciously begun a project whose completion we will not personally witness. This may be our civilization's first truly multi-generational endeavor. As the receiving arrays settled into their listening mode, Dr. Vasquez offered a closing reflection that would be remembered long after the technical details of the transmission were forgotten. The question that has haunted humanity since we first gazed at the stars, "Are we alone?" has been answered. But that answer has given birth to deeper questions. Who else is speaking? What conversations have occurred before we joined? How will our voice contribute to this ancient dialogue? Today marks not an end, but a beginning. We have spoken our first intentional words to the galaxy. Now we must develop the patience to listen, the wisdom to understand, and the continuity to maintain this conversation across generations. 3I Atlas showed us how to speak to the stars. Our challenge now is proving we have something worth saying. As night fell over New Zealand, observatory staff gazed upward at the same stars that had inspired human wonder for countless millennia. But tonight, those distant lights held new meaning. Somewhere among them, our message was traveling outward, at the speed of light, a deliberate introduction rather than accidental leakage. For the first time in our planet's 4.5 billion year history, Earth had intentionally announced its presence to the cosmos. Whatever response awaited in the distant future, this moment had irrevocably transformed humanity's relationship with the universe. We were no longer just observers of the cosmic drama, but participants. Whatever happened next would depend not just on who might be listening, but on who we chose to become.